Here we go. That works. How is it? Tokyo, thank you for having me. It's good to be here. I hope that you can understand some of my thoughts and my feelings. There's a lot in my life that I would give credit to Japan or inspired by Japan, and I hope some of that will be clear to you from this presentation today. Also in English, normally I speak very fast, and some of my ideas are sort of crazy. So hopefully the interpreters will be able to give you the true sense of my thoughts. So we live in an interesting time. I made this graphic in about 2 seconds with a prompt. This one is Nano Banana on Gemini. Does everyone use AI for something? Yes? Who uses it for coding? Who uses it to make graphics? Who uses it to translate Japanese to English? It's amazing for learning languages. In some ways, we never needed to learn languages less, but the tools to do that are better than ever before. So Alex introduced me. He told a little bit of my story. I don't want to spend too much time talking about myself. At some point, I want to talk about you. But my background was as a software developer who then got more and more focus on operations. And that really began as what I'll call being a conscientious developer, working in a software as a service e-commerce startup, and coming to work after doing deployments, and everything is broken, and no one can buy, no one can check out, and becoming just obsessed with trying to make these systems more reliable for my customers. Then I was a co-founder of Puppet working on a project. And from the beginning, one of the things I really was in love with or fell in love with, which is much longer story, before DevOps was born, was agile software, agile engineering, and particularly test-driven development. So part of my motivation with Puppet was to be able to do the continuous integration of all of the infrastructure, because many of the problems that I was experiencing in software as a service were coming from the differences in the configuration between the development environment and the test environment and the production environment. And after Puppet, DevOps was kind of already born. I went on to work on OpenStack as a VP of engineering for a company sold to EMC. Then I worked on a project called Cloud Foundry. I also worked on some Java and Spring at Pivotal. Does anyone use Spring? Java stuff? No? And then last but not least, Kubernetes. And as mentioned before, I was organizing DevOps days from the beginning, writing books, and doing kind of this kind of work for Pivotal and Red Hat until I started my own company, which I call Ergonautic. And with my friends, we don't care what technology. What we care is how you work. And there's ideas that I was influenced from stuff happened in Japan, which we'll get to, but it's more about thinking about the flow of work than choosing a technology. Technology will not save you from problems with your systems. I was told this is classical Japanese. It may be difficult for reading. But this is a invasion of the island. The Mongolians tried to invade the island. And this roughly translated to English says something to the effect that when the Mongolians came, according to our manner of fighting, we must first call out by name someone from the enemy ranks and then attack in single combat. But they took no notice at all of such conventions. So before the invasions, most of the wars that were on the island were duels, 1-to-1, one person, one person. And the Mongols did not conquer the island, but the invasions changed Japan forever, and particularly had an impact on the economics and the rewards of the samurai system. Before the Mongolian invasion, the samurais were rewarded for winning, but in this case, the war is defensive. So there's no reward for winning when you're defending. There's nothing to give to the winners. But it strengthened the notion of Japanese unity and identity. So right now, we have a tradition of assigning tasks to people. In many of our places of work or the projects we do, it's like a duel, one person against one task. But they took no notice at all of such conventions. Do people know this project, OpenClaw? You know this? So this is something, it will probably be different in 2 weeks, but right now people are excited about this project. It was one of the fastest growing projects on GitHub. And people were buying Mac minis to run these little agents that will do everything. So if you haven't seen OpenClaw, maybe something to look at, but it's a agentic framework. And I just thought it was, again, this was me with the prompt. Gemini, I make a picture. I told it to make a picture of a Japanese programmer using the AI to solve problems. But it's no longer one person doing one task. Now every single person in this room can have a small army of agents doing whatever. So there's a bunch of quotes. Some of them from me. This one's from me. Learning is the only sustainable advantage. You're either building a learning organization or losing to someone who is. So this is from talk in 2013, old ancient traditional DevOps days. This is from a talk I gave in 2014. So this was, I'm not going to give this talk today, but in 2014 in Austin DevOps, I gave a talk that was more or less going through Miyamoto Musashi, Gorin Nosho, and these principles of Musashi. And I think this is good advice for anything you do, forever. And then maybe the most important thing, also from 2014, my friend Bridget made a game. And this game is the black cards are questions and the white cards are answers. So you play this game by, everyone has white card, you put it in for the answer for the black card. And this is the most important answer, is to solve all your DevOps problems. So learning is the only sustainable advantage. And now our systems learn too. We'll keep coming back to this. So this is me today. So does everyone know DevOps started in the 1950s? Started before that, but we'll go to the 1950s right now. So there's a researcher, his last name is Trist. He's British. And he coins this terminology, socio-technical systems. And he does that studying the mechanization of the British coal mines. And there's a whole long story. This could be another hour talk. But the coal miners, they have central planners who are making big investments in automation. And they believe that this will increase productivity and it will decrease the incidents. But what happens in some of the cases that he studies is the introduction of the mechanization actually does not increase the productivity. It increases the incidence of accidents and decreases safety, and it significantly lowers morale. And the problem, and this notion of social technical systems theory, this is the one sentence definition, is that the quality of any organization, any organizational system can only be understood and improved if socio and technical are both considered as interdependent parts of a single system. You can't just take the technology and throw it into the middle and expect good results if you don't account for the changes that the people that are doing the work have to make, then it won't improve the way you predict. These are the papers. These are points that are made in the papers from the 1950s study on mechanizing coal mining. So from the 1950s, some of this might sound familiar. They're talking about the old paradigm being a focus on the technological imperative. The new paradigm in 1950s is man as a complement to the machine and a joint optimization of the man and the machine. I won't read all of these, but I want to skip to the organization chart. So the old paradigm in 1950s is a very tall org chart and a very autocratic style. So the boss says it, you just do it. But the new system in 1950s is a flat organization and participative style. Everyone's participating. And that leads to the difference between, going to the bottom, alienation and commitment. And Tris is arguing you'll get better outcome, better results if people are committed to the outcome. And then last but not least, and maybe my favorite, the old paradigm is low risk taking. But the new 1950s paradigm is innovation. That sounds familiar. So just to remind you, this is a paper studying 1950s coal mining. It's like we have to remember everything. We forget. Humans are forgetful. So also in the 1950s, there's a person, I feel like he had a very big impact on myself, on my understanding of this work. And without Deming, I don't think you would have Devops as it exists today. So in the 1950s, Edward Deming came to Japan. Are people familiar with the Deming Prize and some of this stuff that Deming did in Japan? Yes? If not, we can look it on Wikipedia afterwards. So I have a few quotes from Deming. If you don't understand how to run an efficient operation, new machinery will just give you new problems of operation and maintenance. The sure way to increase productivity is to better administrate man and machine. So this is Deming quote, but that's almost identical to the lessons from Trist and the coal mines. Almost an identical lesson. This is a documentary that you can watch on YouTube where Deming's older, so he came in the 1950s, so this is in the 80s. And they're talking about the auto industry and the rise of the Japanese auto manufacturers competing with the American manufacturers. And a quote in this, which I'll read, I think that people here expect miracles. American management think they can just copy from Japan. but they don't know what to copy. So without Deming, there'd be maybe no Toyota, no Lean, and no DevOps. So in this time, the American executives visit Japan and they see the factories. And they thought the Japanese were hiding the truth because the American understanding could not understand that how you could make cars without a huge stockpile of inventory. So when they could not see the inventory, they thought the Japanese must be hiding the inventory somewhere. They're hiding it somewhere from us. But they saw the robots. They saw the robotic factories. And they went back and they decided they were going to build factories like this, like the Japanese. So I will read from this middle part. So in the 1980s, GM spent 45 billion US dollars in 1980s money. And despite that spending, its market share rose a single percentage point to 22%. For the same amount of money, we could have bought Toyota and Nissan outright, which would have instantly bumped GM's market share to 40%. So now there's some quotes from the GM executives, which maybe we can learn a lesson about what we're going to see with our own work. Quality suffered because instead of making flawless cars, workers simply did their assigned jobs. Workers had no big picture goal of building cars together to motivate them. Focusing on the technical without accounting for the social never goes well. All you do is automate confusion. So these are quotes from the GM executives after they spent $45 billion. So this quote may not make sense, but I like this quote in English. I hope the translators can capture the feeling of it. But this is a famous Deming quote. It is not necessary to change. Survival is not mandatory. And it's sort of a sarcastic joke, but he's basically saying you don't have to change because you can just die. I think this is always true. But sometimes it is more true. Maybe today. More Deming. If you can't describe what you're doing as a process, you don't know what you're doing. It is not enough to do your best. You must know what to do and then do your best. Rational behavior requires theory. So I won't spend too much time on this, but I'm going to hopefully build up to a point that will make sense. This is from the Wikipedia article about control loops and control theory. This is how all robotic stuff works. This is how the thermometer works. But the basic idea is that you have some reference that you're measuring, a controller that makes decisions, that is going to put some action into the system, and that's going to change what the system does. And then you're going to measure that with the sensor, and that's going to go back through a loop. And this is the basis for like so much automation. And people like making loops and like changing the branding, putting a new logo on the loop. But I think all loops are the same. Circles are the same. And in Japan and in a lot of the Eastern traditions, there's lots of cycles, so like very much the same. So I think these are all the same. All these loops are topologically equivalent, which is just fancy mathematical way to say everything that's a circle is the same. So if you read these things or you started to train or think about AI, this isn't necessarily applying to AI, but it's very much the same idea as reinforcement learning and some of these things that you have some action that acts on the system, which makes more information, and you're trying to do the same thing with the controller before. Although here I didn't put the system. But then people added this idea, this theory of the two loops, because you have some assumption about how the world works that's driving the decisions, just driving the actions. And if your actions aren't working, then maybe you need to change your model. You need to change your assumptions. And this is sort of how reinforcement learning works. It's like you're measuring in these things and changing the cycles. So this is just an abstraction. And one of the points I want to make on this is you're going to make moves and measurements much more frequently than you're going to update your model. If you think about how you do work with AI, right now you're probably not getting a new model every minute, every second, but you might be doing tasks every second, right? And you might be testing and measuring things every second. This is also, you could map this onto the cycle from Deming: plan, do, study, adjust. And I'm going to use this graphic a few times, but it's exactly the same as the controller before. I just tried to make it a prettier version. So you have something that models the system, that controller makes decisions, then there's something that acts on the system. The actions have an impact that can be measured, and that creates information, and you just go in this loop. Now, one of the points I like to make on this slide is you can improve the system by improving any one of these things. You could improve the actions you could take. You can improve the quality of your measurements, and you can improve the model, the quality of the decisions. This is a drill down to something maybe some of you are familiar with if you've ever used Kubernetes or Puppet, that you have some measurement. You're looking at the desired state of the system against the current state of the system. You're making some comparison of those two and making a decision about what to do or not to do. So this is exactly how Kubernetes reconciliation loop works. This is exactly how Puppet and Chef worked. This is also what I argue you're doing when you're doing test-driven development. This is also exactly what all of these agentic frameworks are really doing. So you're setting up some model that you're going to make actions and then take measurements and just loop through that until you get to the desired outcome. It's the same cycle. Do people use this terminology evals in their AI journey? Maybe you can look this up. Evals is it's hot topic. So what data are you capturing? How does data drive decisions? Lots of people can make lots of actions. It doesn't necessarily improve the system. So how do you know what is better? This is the key to the controller, the model. So have you ever explained what you want and received exactly that? Does anyone have kids? Have you ever told your kids to do something and they did it exactly how you wanted them to? Have you ever explained to the AI what you wanted and it did exactly what you wanted it to? So you got to learn how to express yourself. But the other side also has to take the information and do something with it. So this is what I call the AI doom loop. So you say you want something and you get 80% of what you wanted. And you're like, no, that's not what I wanted. It was almost what I wanted, but do this other thing. Do this other thing a little different. And now you have 85% of what you wanted. And you're like, no, here's this other 15%. Just change this 15%. Leave everything else, but change this 15%. And then you now get 70% of what you wanted. And you're like, no. And then you get a different 80%. And then that goes on forever. Anyone have this happen before? Happens all the time. You know that you need to start over as soon as an LLM apologizes. When it says sumimasen, you have to start over. And this problem may be because the thing you're trying to solve is too big for the model. It's too big for one communication. And the solution is to decompose the problem. There's some interesting research that came actually from Chinese researchers showing productivity with AI tools based on task decomposition. The ultimate strategy improvement came from the right decomposition of tasks. And I believe this was always true. When you think about lean, when you think about flow, it's really a question of how do you get the right decomposition of tasks? How do you get the right size of tasks? How do you get the right order of tasks? This is the same, whether it's people or technology. The most important thing that Toyota produces is not a car, but the system that produces cars. A bad system will beat a good person every time. This is our friend, Deming. So this is my ideas, applying some of the things we saw with the models to socio-technical. So the left side, the beliefs and behaviors is what I call the socio loops. And then skills and tools are the technical loops. And these are feeding back on itself. So if you have certain beliefs, then maybe it's hard to use tools in a new way. And if you have certain tools or certain skills, maybe sometimes it's hard to have new beliefs. So this is happening in every layer of an organization. Every skill and every layer of an organization has different understanding, different model, different tools. So I hope this idea will come through because it's related to how I think about agentic frameworks as well. And this idea here is that you have, think of this as an org chart. So the top is the executives, and then the middle is kind of the managers, and the bottom is the people who do work, practitioners who do work. And it's what I started using this language of delamination and disintegration. So delamination is when there's some disconnect in the information, the beliefs of the leadership and the managers and the people who do the work. So this is starting to separate. So the people at the top believe one thing, the people at the bottom might believe something different. And then you have disintegration as a disconnect between capabilities. This is more like the classic DevOps divide, the DevOps silo. So that there's something that is misaligned between two capabilities. So these delaminations and disintegrations result from conflicts between selfish interests, selfish perspectives, and the collective interests. Are we one team? Are we one group? Are we one company? Are we one country? Another good quote. People with targets and jobs dependent upon meeting them will probably meet the targets even if they have to destroy the enterprise to do it. So this is Deming. And I'm going to say, That's also true with your agents. And you can spend all the tokens in the universe with agents undoing each other's work or having different things trying to optimize for this security, development, operations, back and forth forever because they're not aligned on the outcome. Each one's trying to optimize for its selfish interest. Small misalignments can prevent big progress. A bad system will beat a good agent every time. Deming, probably. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This is a very famous quote. Melvin Conway is a computer scientist from the 70s. Sometimes people refer to this as Conway's Law. So Conway's Law, I believe, rules everything, but now with more AI. So how do the agents communicate with each other? How do the agents get their incentives aligned? Quality is pride of workmanship. Another Deming quote. Coming towards the end. Excellence is never an accident. It is always the result of high intention, sincere effort, and intelligent execution. It represents the wise choice of many alternatives. Choice, not chance, determines your destiny. Deming? No. That's like 2,500 years ago. Aristotle. Timeless. It's like the same patterns over and over. Change is hard. So this is something I used to get frustrated with when I would try to teach people about agile, when I try to teach people about DevOps, and they would use the words, but change nothing else. And I think we saw this with agile. I think we saw this to some degree with DevOps. I don't work in Japan, but I imagine similar. And then maybe the new word was SRE, Site Reliability Engineering. And then there's a new word, it's platform engineering, but no one changed anything. And I got frustrated, but I found this research, academic framing for why this happens. And it's really interesting because in the beginning, the innovators and the early adopters are actually trying to win a game. They have a clear game that they're trying to win. That's their motivation. So they are seeking an advantage in a game. And then because they're trying to get an advantage, they start to win. And because they start to win, that language and those practices get what I'll call legitimized. And then because those are legitimized, as you come into the majority, these organizations, they're not trying to win. They're trying to use the words that they saw the people who are winning use. They're trying to use the tools that they saw the people who are winning used. But they don't change all the things that they would need to change to actually get the results, to win the game that the early adopters and the innovators were trying to win. I don't work where you work, but I have seen this many times. So if you are seeing this, experiencing this, it's maybe normal. But also, my advice to you is to seek an advantage. Figure out the game you want to win and win the game. That could be for your company. That could be for yourself. Because one of the things I also believe, I didn't put this in the slide, but it's kind of implied by the open claw. Every person on the planet that has access to these AI tools can build anything they imagine. The only thing between you and building anything you can imagine is a little bit of time, a little bit of maybe some tokens, some money, um, and being able to express it clearly, being able to speak it into existence, right? Earlier in the icebreaker, there was the question, what is the programming language you use? And people said Java, people said Go, Python. Right now, maybe the most powerful programming language is English or Japanese, or just in telling the thing to make this vision that you have. How many times we say something doesn't matter as much as how many people still need to hear the message. This is a famous historical document. This, this is the memo from Bezos in 2002. Bezos sent something to look close to this, and I'll just read the top and the bottom. So the top, he says, in 2002, all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. So this is the beginning of what becomes Amazon's advantage. This is the beginning of what becomes Amazon's cloud capability, is forcing people to use APIs for everything to communicate. And then the end, anyone who doesn't do this will be fired. Thank you, have a nice day. And the detail that people dispute is true is people who worked there at the time say he would never say thank you, have a nice day. So in many ways, if you worked in operations or system administration before cloud, the cloud was kind of like the Mongolian invasion. It's like nothing was the same after the cloud. Everything you did before, you could keep doing it, but it wasn't going to win the game. It's not an advantage. And AI is just the new wave, the next wave. So I don't know what will happen. There's a lot of predictions. A lot of people like to make predictions. All I know is you can catch the wave. You can surf, right? You can be smashed or you can surf the wave. So what will be the new memo? What will be the new manifesto? So these are actually Deming quotes as well. I am forever learning and changing. We are here to make another world. We're here to make a better world. And I feel like this is my personal DevOps manifesto. Whatever you think DevOps means, whatever practices, whatever tools, doesn't matter. What matters is that you are forever learning and changing, and you're here to make a better world. So I'll sign my name to that. Hopefully you'll sign your name to that. You haven't learned anything until you change your behavior. So this goes back to the comments about seeking advantage and seeking legitimacy. If you get a new word, but you don't change the behavior, you didn't actually learn. This is very easy to demonstrate with other skills. If you want to become better at playing music, if you want to become better at a sport, if you want to become better at chess, if you learn something, but you can't do it, then you didn't learn it yet. You just have the trivia. You just have the idea of it, but you cannot do it. You have to do it in reality. This is true for you. It's also true for your agents. If your agents don't learn, they don't change their behavior, even if you lost, then you're going to lose more. So this is kind of like the beginning when I had the the invasion and the discussion about Japan changing. So AI will not solve DevOps, but it will change DevOps forever. Potentially change the economic rewards and structure of the system. So what will we do? This is another quote, older time. Waste no more time arguing about what a good DevOps should be. Be one. That's another old guy. I don't know how to pronounce that, but I'm sure the translator will do a good job. Knowledge must be tested in reality. That's the best we could do. So with that, thank you for listening. This is where I was yesterday morning. Domo arigato.
Thank you very much. That was great. We've got some time for questions and answers after this. So I will run around and get questions from either English or in Japanese. So think of some questions and just put your hand up, and we will come and ask you a question, or we'll get your question if you have one. So please think of one. But while we wait, I have a question.
Let's hear it.
So you mentioned at the beginning the 1950s coal mining consulting or something like this, right?
Yeah, so the Tavistock Institute was studying the coal mining, the mechanization of the coal mines.
So it sounds like they were teaching and learning the same lessons that we're learning here in DevOps and in Agile and in similar. Does this mean we've actually learned nothing since then?
So first I'll quote one of my friends and my business partner. We had a conversation where we were talking about Deming, and he said when he first read Deming, he wanted to throw the book, and he was sad precisely because of what you just said. It's like we have all these answers right in front of us, but for whatever reason we don't do them. So in some sense, I feel like as a collective, we maybe don't move, but as individuals, we can. If you've ever worked in a place that has embodied certain principles, once you have worked in this place, you never want to work anywhere else. You never want to work any other way. So I feel like some of us touch on these experiences, and then we want them forever. And if we can get them, we will get them. And if someone else is in charge, maybe they will wash it away. Because at least in the US, I don't know how it works here as much, but in the US, for a new executive, they feel like they have to prove their value by changing a bunch of things. So they come, and a lot of things that the other person did might be great, but they will erase them because the other person did them.
That's a really good observation. Yeah, I agree with that. Or very interesting. Yeah, interesting way to look at it. So any other questions that for Andrew here? And of course, after the talk, feel free to ask too. I see one. Let me make it to the back here. Okay. Go ahead.
Hi, interesting talk. What would you say or a recommendation about the near future? Because you mentioned that AI and all these things are coming for us, but maybe as engineers, what would you recommend us to start focusing in the near future?
So the high level, I gave you the advice that you should always be learning and changing. So that will apply to everything. But in specific, I feel like my best information comes from the network of people that I've built and being able to see what my smart friends are doing. So I'm pretty smart and I can go find information, but if I can see what other people are doing, then that helps me learn that much faster. So definitely learn, definitely change by yourself, but it's really about the power of the collective and building a network of colleagues and friends that are going to push your level higher and higher. So, and then in specific, like right now, there's a bunch of hot things, like everyone's doing Claude Code where I am, but that will change in 2 weeks. So don't worry about what is the fashion of today. Worry about the principle of learning forever.
はい、
Listen to the English.
日本語で、質問するテストを兼ねて質問をしようと思います。大丈夫ですかね。通訳聞こえてますかね。大丈夫ですか。
I can hear the voice. Yes,
あ
translate.
りがとうございます。え今日は非常に素晴らしいスピーチトークありがとうございます。Devops Days を日本でも私たちのこの会議になってからもう10年近く Devops Days をやってきました。で、その、源流のアジャイルアーキテクチャー、インフラストラクチャーを提案された2009年、2008年でしたっけ、の時からずっとこう、DevOps、もうその前から DevOps のようなこととか、このあたりのことをずっと見てこられた、アンドリューさんならではのすごく深いトークだったかなというふうに思って聞きながらすごく感動してました。で、感動しすぎて特に質問が浮かんでこないんですが、すごく共感する、今日のトークですごく共感するポイントがありまして、ちょっと再来週、グローバルスクラムギャザリングでトヨタの人と一緒に喋ってくるんですけど、やっぱり同じことを言ってました。いろんなプラクティスがあって、それを真似て私たちはやろうとする、もしくはそのフレームワークだけ、私スクラムのカンファレンスもやってるんですがフレームワークだけ入れてみて、会議をこういうイベントがあればスクラムだよね、うまくいくよねというふうなことを言ってみんなやるんだけど、結局一番大事なのは何だったっけっていうところはやはりやってみないと分からなくて、自分たちの仕事そのものを変えてみて初めて、それが何だったのかっていうのが、言語化できるかどうかちょっと置いといて少し分かってできるようになると、これの繰り返しを私たちずっとやってきた感じがしますということで、その点にトヨタのやり方を、欧米の方がコピーしようGM とかの方がコピーしようとしてなかなかうまくいかなかったけど、ヌーミーとかで一緒にやって、初めてできるようになったような話も聞きます。やはりそういうことがたくさんあるのかなというのを感じて大変勉強になりましたというか大変良かったですコメントですいません。
Thank you very much. The insights that you have and kind of the journey that I was on, I'll tell you, just kind of on the comment that you have to put it into practice. It has to be real. Before DevOps was a word, so I showed the Bezos memo, and the Bezos memo was from 2002. In 2006, there's a famous interview with Werner Vogels, who is the CTO of Amazon. And in this interview, he says a very famous quote, "You build it, you run it." In fact, many people will say this is a DevOps quote, but this is 3 years before DevOps was a word. So there's all these practices that are emerging inside of organizations like Amazon, Google, the big web, Facebook, whatever, that are the practices that eventually come into what people call DevOps. When I first was talking about these ideas, I called it agile infrastructure. And when people started making the word DevOps, I didn't like it at first. I thought it was just going to confuse people. But and it probably did confuse people, to be honest. But the practices are what matter. So there's another. I'll make a maybe know this movie, maybe you don't. But there's an old movie, Seven Samurai, and in this, there's a scene where there's a swordsman who's the best swordsman, and he's facing another swordsman, and they decide to have a duel with wooden swords. So they're facing each other, and they make a movement, and one of them, they both basically stop with their swords on each other, and one says, "We'll call it a draw." And I think his name's Kenzu or something like this. He says, "If we fight with real swords, I'll kill you." And the other guy gets mad. And then he forces a duel with real swords, and he loses. Like they do exactly the same movements. And the samurai, the one that said, "If we fight with real swords, I'll kill you," he cuts him, and it's over. And I think in many cases, people that cannot fight with real swords are talking about how they would win, but they don't really have to test it in reality. But we still listen to them because they have a good voice.
Well, I think we have time for another question or two. So if anybody has any thoughts, the bento lunch will be ready here in a moment. Yes.
お話ありがとうございました。現行の話になぞらえて、今まではエンジニアが一人の戦士として一つのタスクと戦ってきたけれども、これからAI っていう軍を率いていくんだっていうお話をされてたと思うんですけど、シニアエンジニアのレベルだったらAI っていう軍を率いても戦っていけると思うんですけど、ジュニアレベルのエンジニアってまだ難しいかなというふうに思っていて、そのジュニアエンジニアの立ち位置とか、その育成方法とか、そういうのってどうなっていくって考えられてますか？
This brings a very good point. And I think it's almost true, but not quite, because there's a value to knowing how to do something right. You have to know the right model. This is from the quote from Deming. Like, you have to know what to do, then you do your best. And there's many engineers that are senior, but they don't necessarily know better than the junior. They just been there longer. And there's also junior engineers who are embracing the AI native process. They're embracing the power of these tools in a way that some of the senior engineers might be resisting. So I think that there's definitely this imbalance, and you're going to see in organizations, inside of organizations, and across industries, a separation between those who have adopted these tools and get superpowers, super capabilities, and those who will be left behind, those who will not get the advantage. So to answer the question, the direct question about how do you get these skills, if you use these tools as tutors to learn skills, they are fantastic at explaining all of these things that you want to know. So what you need as a junior engineer to get to these higher levels of capabilities is the curiosity to ask the questions, the curiosity to make the LLM explain its own reasoning, and treat it as a tutor, treat it as you would any other teacher that you want to get all of the information out of. That's what will make the level of anyone's individual practice go up faster than anything. Take the tools and make them explain what they did, and then just iterate forever. always learning, always changing. わかります。
ありがとうございます。
Thank you very much. Well, that was fantastic. Thank you so much, Andrew. We all very much appreciate it.
Thank you so much for having me.